Alright, so question 3, it says that the sixth term of an arithmetic progression is 23 and the sum of the first terms is 200. Find the seventh term. So this question is a arithmetic progression question. Well, the first part that is. Alright, and so it says the sixth term of an arithmetic progression is 23. Now, what do we know about the arithmetic progression? Arithmetic progression, AP. We know that the arithmetic progression of a first term of A, right? It have a first term of A. Then the next term we know is that it have a common difference D. So it is A plus D, then A plus 2D. And that continue up till the last term is A plus N minus 1 times D. This is what we know how our arithmetic progression should look. And now what this question is telling us is that the sixth term of the progression is 23. So the sixth term, I like to call it term 6. Term 6 is going to be equal to A plus 5D. So that's our sixth term, A plus 5D. Our first term is A, the second term is A plus D, the third term is A plus 2D. So the sixth term is A plus 5D. Now A plus 5D is equal to 23. That's what it's telling us, right? So A plus 5D is 23. Now the next part that it says is that, and the sum of the first 10 terms is 200. The sum of the first 10 terms is 200. So the sum of the first 10 terms is S10. That's the sum of the first 10 terms. Now what is S10? S10, remember the formula is N over 2 times 2A plus N minus 1 times D. That's the formula for n term of an arithmetic progression, right? But what do we know? We know that n is 10 because the sum of the first 10 terms we're adding, and so n is 10. So we can replace n with 10. And so it's really S10 is 10 over 2 times 2a plus n minus 1. 10 minus 1 is 9. So rewrite this as 9d. So 2a plus 9d. And then 10 over 2 is just 5. And this works out to be 5 times 2a plus 9d. And 5 times 2a plus 9d, it's working out to be 5 times 2a is 10a plus 5 times 9 is 45d. And so we get 45d. And they said that the sum of the first 10 terms is 200. And so 10a plus 45d is 200. So now clearly what we have is a simultaneous equation, right? So we have a simultaneous equation where, let me just change up the colors. So what they're telling us is we have 10a plus 45d is equal to 200. And then we have a plus 5d is 23. Now this a plus 5d, I'm gonna write it back right here now. A plus 5d is 23. But what if I were to multiply the second equation by 9? If I were to multiply this equation by 9, right? If I were to multiply this equation by 9, I would get 9a plus 45d and then 23 times 9. And 23 times 9 is 207. So what I get is 207. So that's what I want to do. Now, what I can then do is subtract these two equations because I'm using elimination method. And what I find is that 10a minus 9a leave me back with a. 45d minus 45d, that gone. Now 200 minus negative 207 leave minus 7. So I'm getting that a is negative 7. So the first term is negative 7. Now that I find that a equal negative 7, then what I know is that plus 5b, a plus 5b is 23. And so what that tells me then is that negative 7 plus 5b is 23. And so what that telling me then is that 5b, so this is telling me then that 5b is equal to, 5b is equal to, this looks like, bring over the negative 7 to get 30. And so this is pretty much telling me that b is equal to 30 divided by 5, which is 6. So now since I find the first term a is negative 7 and the common difference b, which is 6, the question wants the seventh term. So the seventh term, I like to call it T7. T7 is going to be equal to a plus n minus 1 times b, where n is now 7, so it's a plus n minus 1 times b, and a is negative 7 plus n, which is 7, minus 1, which is 6, so it's 6 times b, so it's negative 7 plus 6 times b, which is 6, and negative 7 plus 6 times 6, that is 6 times 6 is 36, 36 minus 7 is 29. And so the final answer is 29. So we can write that the seventh term is 29. That's the answer. Easy, soft. That's the answer. 29. Very easy. All right, now we're going to look at the second part. And the second part gives us a geometric progression has a first term of 1 and a common ratio of r. A second geometric progression has a first term of 4 and a common ratio. Alright, let's make some space. So it says a geometric progression has a first term of 1 and a common ratio of r. A first geometric progression and a second geometric progression has a first term of 4 and a common ratio of a quarter r. The two geometric progressions have the same sum to infinity. Find the values of r and s. So let's work this out. So the first geometric progression has a first term of 1. So what I like to do is I'm going to write first GP. So this is the first GP, the first geometric progression. They tell me that it has something, and then we have a second GP. So I have a second geometric progression. So I'm just writing down the information that they give us about the first geometric progression and the second geometric progression. Alright? So just writing down about the first one. The first geometric progression, again, they said the first term is 1 and it have a common ratio of r. First term is 1 and a common ratio of r. So it tells me that the first term, I'm going to call it a. The first term a is 1 and it has a common ratio of r. The common ratio is r. Common ratio equal r. So that's some information that it tells me right there. And then the next thing that it tells us is that the second GP has a first term 4 and a common ratio of a quarter r. So first term 4 and common ratio of quarter r. So the first term is equal to 4. I don't want to write a this time, so the first term is 4 and the common ratio, I'm just going to write CR, not CR7, you know, just CR, common ratio. So common ratio is a quarter r. That's a common ratio. And then the final part of the question said that given that the sum to infinity of both are equal, find the value of r and s. So they both have a sum to infinity. Now what do we know about sum to infinity? Sum to infinity is equal to a over 1 minus r. So this is the sum to infinity of the first GP, and the sum to infinity of the second GP is a, which is 4 over 1 minus r. And this r in this case is 1 minus a quarter r. Now both s's are equal. Now they said that the sum to infinity of the first GP is equal to the sum to infinity of the second GP. So then both of these together combine. So we can combine these two, just for combining them. So we plug them together, and what we're getting is that a over 1 minus r. And in this case, a is 1. So let me change that as well. The first term for the first one is 1. So this is 1. A is 1. 1 over 1 minus r is equal to 4 over 1 minus a quarter r. So we can cross multiply. And so by cross multiplying, what we're getting then is that 1 minus a quarter r, 1 minus a quarter r is equal to 4 times 1 minus r. 4 times 1 minus r. So what we're getting is that this is working out. So this is working out to just be, just to put an arrow, this is working out to be 1 minus a quarter r, and that's equal to 4 minus 4r. And so what this is working out to be is, when we bring over, we can group them on one side, group the numbers on one side. So let's bring over 1 over to here, and bring over the minus 4 to here. So we can write this now as 4r minus a quarter r, and that's equal to, bring over the 1 over here, 4 minus 1. So what we're getting then is that 4 minus a quarter, 4 is really 16 over 4, and 16 over 4 minus a quarter is 15 over 4r. So we get 15 over 4 times r is equal to 3. And so clearly r must be equal to, what is r equal to? So we just say 3 divided by 15 over 4, and I'm getting 4/5. So r is 4 over 5. So that is r. Now since r is 4 over 5, let's finish the question right here. It implies that s is equal to a over 1 minus r, that is s. And so s is equal to 1 divided by 1 minus 4/5. And so what s works out to be is 1 minus 4/5 is 1/5, and 1 divided by 1/5 is 5. So s works out to be equal to 5. Alright? And so this is the final answer, s equal to 5. So we're going back to the page now with the questions right here. We can say that r, the final answer for this is r is 4/5 and s is 5. So this is a typical arithmetic and geometric progression question. Easy.